In this video, we are going to talk about Amdahl's law. Amdahl's law was proposed by Dr. Jean Amdahl in 1967. Dr. Amdahl, he is pioneer of the mainframe computing. This is Wikipedia. His major contribution is work on the mainframe computer at IBM. He is a theoretical physics. What is Amdahl's law? Amdahl's law is a formula which gives the theoretical speed up in latency of the execution of a task at fixed workload that can be expected of a system whose resources are improved. This is a definition from the Wikipedia, but after reading this one, we still don't know what exactly they're talking about. So let's give a little bit simple term to explain what is Amdahl's law. In a program with a parallel processing, relatively few instructions that have to be performed in a sequence will have a limiting factor on program speed up, such that adding more processors may not make the program running faster. Okay, that is basically says if you only want to add more and more processors, may not really improve the speed infinity. Okay, there is some kind of limitation. This is the mathematic expression for the performance of parallel system and multi-core systems. Amdahl's law express speed up equal to time to execute program on a single processor divided by time to execute program on number of n parallel processor. Okay, the mathematical expression is like this. Speed up equal to 1 divided by 1 minus fraction and plus this fraction divided by the number of the processors. 1 minus f is execution time on a single processor. And n is number of processors. So here has two properties. One, f is smaller. The use of parallel processor has little effect. For example, if you're running very smaller code, which is running very fast, it actually you add more parallel processor, it does not really impact much. In other words, if you programming running a very long period of time and then you separate into multiple processors, that's going to be more effective. The number of the n approach infinity. So it's very large number of the processors. Speed up is bound by 1 divided by 1 minus f. So that there are diminishing returns for using more processors. So there is a limitation for use more processors. That is basically what they mean. In our textbooks has an example. This is very good to explain what is Amdahl's law. That is on your page 47. Example 2.1. Suppose that make extensive use of floating point operations with 40% of the time consumed by floating point operations. With a new hardware design, the floating point module is speed up by a factor of k, then the overall speed is as follows. So after redesigned hardware, maybe add more processors, it's actually they have an improvement factor. So what is can be expressed? This is speed up, maximum speed up equal to 1 divided by 60%. That is 1 minus 40% is going to be 60% plus this 40% of the time divided by this k factor. In this example, if the your improve factor, key factor is very large, is infinity. And then this number is going to very small. So that means is 1 divided by 60%. That's going to be speed up 1.66. Okay, so speed up is going to be only 1.66. So you will see there is a limitation for your hardware redesign to increase multiple processors. Okay, this is the example to well explain what is Amdahl's law. Okay, thank you very much. See you next time.